Welcome back. In this video, we're going to talk about the significant figures or sig figs along with the Atlantic Pacific rule. Now, what we have to remember, obviously it's Atlantic Pacific, but we got to remember if we're thinking about the United States, the Atlantic is actually on this side and the Pacific is on this side. And so the Atlantic Pacific rule is related to if or not a decimal is present or if a decimal is absent. So if a decimal is absent, we're going to start on the Atlantic side. So we have absent. And if the decimal is present, we're going to start on the Pacific side. So for example, if we take a look at a couple numbers, so we have a couple different numbers here to look at. Now, some of them have decimals and some of them don't. If we look at this one, the decimal's present. So we're going to start on the Pacific side of the number, which is this side over here. So the number would be our United States map, for example. The Pacific side would be over here. If you have a decimal present, you are going to start, and when you hit your first number, that's when you start counting the significant figures. Every number after that counts and is significant. That includes zeros. So all of these would count. This is actually 5 significant figures. And that one has 5 significant figures. If we look at this one, again, decimals present, we're starting here. We finally get a number at the very, very end. This one only has 1 significant figure. If we look at this one, decimals present, obviously there's a whole number, so we're going to start with that whole number. Everything after, because the decimal's there, is going to count. So 1, 2, 3, 4, 5 significant figures again. We look at this one. Now this one is absent. The next 2 decimals are absent, so we start on the Atlantic side. As soon as we hit our first number, everything continuing will count after that. So obviously my first number's here, all of these will count. This is 5 significant figures again. But when we look at something like this, there's no decimal. I'm going to start and I'm going to go all the way over here until I finally get my first number. This one only has 1 significant figure. So if I had something like this, 1030000, same concept. If there's no decimal, I go all the way to my first number. The 3, the 0, and the 1 count. So this would have 3 significant figures. So one of the things you want to consider with significant figures is when you're measuring things, it's kind of like the concept of your chain is only as strong as your weakest link. Or if you're talking about a team, maybe the team is only as strong as the weakest player. So if I am measuring devices, and let's say we have different things and different size rulers, different scales, and some people are measuring their scale and they're measuring a sample and it goes to 1.23. And then another group is 1.24, but then another group comes back and just says 1.2, and then another group just says 1. Now we have all different significant values. Obviously these 2 are a little bit more precise because they're reading further. They're getting more detail, they're getting more accuracy in their numbers. This one isn't as good and this one is the weakest. So if we were to compile all them together and we were to try to do an average of their numbers, it's really hard to calculate that because maybe the scale wasn't rated enough. But if we're trying to have some consistency in our work and bring it all together, there's some rules you need to follow when you do math. Now, when you multiply or divide significant figures, your answer has to be with the lowest number of significant figures that's in any one of your values. Again, let me repeat that. If you're going to multiply or divide, your answer has to be with the lowest number of significant figures that's in any one of your values. So let's say, for example, you're doing, again, we'll keep it simple. We're measuring density. So we have mass over volume, and we use one of those masses, so 1.24. But then they come back and someone says, well, the volume was only 15. So this one has 3 significant figures. This one has 2 significant figures. So when we do our math, our final answer can only be in 2 significant figures. So if we take 1.24 divided by 15, we end up getting 0.082 and then 666 repeating. So I can only go with my lower numbered significant figure for my answer. So when I want to put my answer I have to look to two significant figures. So again, this would be the Pacific rule, starting till we get our first number. So these are my two significant figures, but then I have to see, what does this last number do? Does that cause it to round up, or does it cause it to stay the same? So in this case, I would round my answer to 0.083, and then whatever my unit was. Maybe it was grams per milliliter. We have to make sure that we have the consistency, and a lot of times in the New York State Regents, they have questions that say, be sure to list your answer with the correct number of significant figures, or they may give you a number and they will say, how many significant figures are in this value, or maybe it's part of the equation or part of what you're reading, and they might say, how many significant figures were in the original reactant or the original, or the final product. So be wary of significant figures. Again, with the Atlantic Pacific rule, you can easily try to figure out the number of significant figures. There's other rules for addition and subtraction. In those, you line up decimal points, and the decimals are where you're going to look at how many significant figures you have after the decimal. The one with the least amount is where your answer has to be. Multiplication and division, again, a little bit different. I've never seen an addition or subtraction question on the Regents exam for chemistry with significant figures. It's always been a multiplication and division question. So hopefully you found some value in the Atlantic Pacific rule and what and how, or I should say, to determine the number of significant figures in a number. Thanks.